Did you guys catch the mistake I made? I said weight instead of torque. So in the safety factor, the torque of the load and the boom versus the torque of the crane body, this should be 1.5 times heavier than this. So the torque on this side of the equation was 184 inch-pounds. So if we multiply that by 1.5, we get 276 inch-pounds for the crane body and the counterweight, and we only had 234. So technically this is not a safe operation. Well, let's say it's a windy day and load starts to swing. If this side of the equation was 184 inch-pounds, if this swings far enough and long enough, it might go up to 200 or 225 inch-pounds, in which case you get real close to tipping over. Okay, now I've got something for you to do. Get out your trig tables. So I'm going to lower the boom to 30 degrees. The load is the same. The distance obviously is different, longer. So is the distance from the CG of the boom to the pivot point. On this side of the equation, nothing's changed. We've got the torque of the crane body and the torque of the counterweight. So you've got to figure out, run the numbers, find out what the torque of the load and the boom is, multiply times 1.5, and make sure you're less than 234 inch-pounds on this side. Now this is going to be, see, it's pretty close already. So, and then figure out, you know, if there was a heavy wind or something, if your measurements weren't exact, this would be tipping over at 30 degrees. So the next question is, if you're not within the 1.5 safety factor range, how much counterweight do you need to get in the 1.5 range? And maybe you don't have another brick. Maybe you've got a piece of wood that's only 2 pounds. Do you put it, how far away from the pivot point do you put it to get the numbers right? That's your job.